Translation of the graphs of quadratic function. First part, effects of changing the values of a. Given the vertex form of the quadratic function y equals a times quantity x minus h squared plus k, if the value of a is greater than 0 or if it is positive, then the parabola opens upward. Again, if the value of your a is positive or greater than 0, the parabola opens upward. And the minimum value of y is k. Next, if a is less than 0, the parabola opens downward. Again, the value of a is less than 0 or negative, the parabola opens downward. And the maximum value of y is k. In addition, the value of a will tell us the width of the opening of the parabola. Use the graph y equals ax squared such that a is positive and the vertex of this parabola is at the origin. Please refer the table below and observe the values of y. Given that y equals x squared, x would be -2, -1, 0, 1, 2, and the value of y respectively is 4, 1, 0, 1, 4. Use this table of values in creating the graph. So you start creating your graph with putting the x and y axis, then fill in using the domain and range the points found in the table of values. And then form the parabola by connecting all the center points. So this is our first graph. Next, in our second table of values, we have here y equals 2x squared. Same values of x and the values of y respectively will be 8, 2, 0, 2, 8. So if x is -2, y would be 8. X is -1, y would be 2. X is 0, y would be 0 still. And then if x is 1, y will be 2, and if x is 2, y will be 8. So in that case, this would be the graph. The color blue graph here represents y equals 2x squared, and the color black graph represents y equals x squared. Third, y equals 1/2 x squared. The value of x is still -2, -1, 0, 1, 2. And the value of y respectively is 2, 1/2, 0, 1/2, 2. In this case, this will be our graph. So the color red graph there, or parabola, represents y equals 1/2 x squared. Graphically speaking, the graph of y 2x squared is narrower compared to y equals x squared, while the graph of y equals 1/2 x squared is wider than the graph of y equals x squared. A similar property can be seen when a is less than 0. I repeat, as you can see, when you have y equals 2x squared, it is narrower compared to y equals x squared. And if you have y equals 1/2 x squared, it is wider compared to y equals x squared. Again, similar property can be seen when the value of your a is negative or less than 0. In general, we could say that if absolute value of a is greater than 1, then the graph of y equals ax squared will be narrower than the graph of y equals x squared. And if the absolute value of a is less than 1, the graph of y equals ax squared will be wider than the graph of yx squared. Again, if the absolute value of a is greater than 1, the graph is narrower compared to y equals x squared. And if it's less than 1, then the graph will be wider compared to y equals x squared. So let's have some examples. Direction. Determine the opening of the parabola and whether the given function is narrower or wider than the guide function y equals x squared. Number 1. Y equals 5x squared. The value of your a here is 5, and 5 is greater than 1. That means it opens upward. At the same time, it is narrower compared to y equals x squared because it's greater than 1. Next, number 2. Y equals negative 4x squared. It opens downward because the value of your a is negative, and it is narrower still compared to y equals x squared because the absolute value of negative 4 is 4 and it is greater than 1. Number 3. Y equals negative 1/2 x squared. It opens downward because the value of a is negative, and it is wider compared to y equals x squared because the absolute value of negative 1/2 is 1/2 and it is less than 1. So it is wider compared to y equals x squared. Translation of the graphs of the quadratic function, Part 2. Effects of changing the value of k. Last time we have discussed the effects of changing the value of a. This time, let's discuss the effects of changing the value of k. The value of k equals 0 and y equals x squared. If k is equals 1, we will have y equals x squared plus 1. And if we have k equals negative 1, we have y equals x squared minus 1. Again, if k is 0, we have y equals x squared. And if we have k equals 1, we have y equals x squared plus 1. And if we have negative 1 as our k, we have y equals x squared minus 1. Let's start with y equals x squared. The value of x is negative 2, negative 1, 0, 1, and 2. And the value of y respectively is 4, 1, 0, 1, 4. You draw first the graph with the x and y axis, and then put the ordered pairs. So you have here negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So those are the 5 points with their corresponding location. Next, you have here y equals x squared plus 1. In this case, the value of your k is positive 1. So the value of your y will be 5, 2, 1, 2, 5. So if x is negative 2, y is 5. If x is negative 1, y is 2. If x is 0, y is 1. If x is 1, y is 2. If x is 2, y is 5. So that would be the graph. So the black graph there represents y equals x squared, and the blue graph represents y equals x squared plus 1, where the value of your k is positive 1. Next, y equals x squared minus 1. This time, the k is equals to a negative 1. So if x is negative 2, y is 3, x is negative 1, y is 0. X is 0, y is negative 1. X is 1, y will be 0. X is 2, y would be 3. So the color red graph represents y equals x squared minus 1. So graphically speaking, by looking at the graph, the graph of y equals x squared plus 1, where k is equals to 1, it shifted one step above than the graph of y equals x squared. While the graph of y equals x squared minus 1, where the value of your k is negative 1, it shifted one step below than that of y equals x squared. Still, a similar property can be seen when a is greater than, when a is less than 0, or if the value of a are negative. In general, the graph of y equals ax squared plus k, where k is greater than 0 or where k is positive, it is obtained by shifting the graph of y equals ax squared by k units above. Again, if the value of your k is positive, the graph of y equals ax squared shifted k units above, while the graph of y equals ax squared minus k, or if k is less than 0, or if k is negative, it is obtained by shifting the graph of y equals ax squared by k units below. It means you're going to shift the graph of y equals ax squared k units below. Examples. Write the equation for the parabola described using y equals 2x squared as the guide function. Number 1. The graph of a quadratic function is shifted 3 steps below the origin. The answer for the equation of the parabola is y equals 2x squared minus 3. Since the graph of a quadratic function is shifted 3 steps below, then we could say the k is negative, and it is 3 steps, that means negative 3. And by using the guide function y equals 2x squared, where the value of a is 2, we will have our equation y equals 2x squared minus 3. Number 2. The graph of a quadratic function is shifted 5 steps above the origin. The equation of the parabola is y equals 2x squared plus 5. Since the graph of the quadratic function is shifted 5 steps above, then the value of our k is positive, and since it's 5 steps, so it's positive 5. And by using the guide function y equals 2x squared, where the value of a is 2, again, the equation of the parabola is y equals 2x squared plus 5. Number 3. The graph of a quadratic function is shifted 10 steps below the origin. The equation of the parabola is y equals 2x squared minus 10. Since the graph of a quadratic function is shifted 10 steps below means negative, so the k of your, or the value of your k would be negative 10. And by using the guide function y equals 2x squared, where a is 2, we will have our equation of the parabola y equals 2x squared minus 10. Translation of the graphs of a quadratic function, Part 3. Effects of changing the value of h. Last time we have discussed the effects of changing the value of k. This time, let's have the effects of changing the value of h. So, the value of h equals 0 and y equals x squared. If h is 1, we have y equals quantity x minus 1 squared. While h equals negative 1, we have y equals quantity x plus 1 squared. Again, if h equals 0, the equation of the parabola will be y equals x squared. But if you have h equals 1, we have y equals quantity x minus 1 squared. While h equals negative 1, we have y equals quantity x plus 1 squared. Now refer to the table shown in this slide. So we have this already, given that x equals negative 2, negative 1, 0, 1, and 2, y equals x squared, where a is 1, h is 0. So you will have there this graph. So the black graph represents y equals x squared, showing the 5 points negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Next, y equals quantity x minus 1 squared. Values of x are the same, negative 2, negative 1, 0, 1, and 2. And the values of y respectively is 9, 4, 1, 0, 1. If shown to the graph, this will be the graph of y equals quantity x minus 1 squared, the one with color blue. Next, we have here y equals quantity x plus 1 squared, where the value of our h is negative 1. So if x is negative 2, negative 1, 0, 1, and 2, the values of y respectively will be 1, 0, 1, 4, 9. So if shown with the graph, color red graph represents y equals quantity x plus 1 squared. Graphically speaking, the graph of y quantity x minus 1 squared, where h is positive 1, it shifted one step to the right than that of y equals x squared. While the graph of y equals quantity x plus 1 squared, where h is negative 1, it shifted one step to the left than that of y equals x squared. Still, similar property can be seen when a is less than 0. So in general, we could say that the graph of y equals quantity x minus h squared, or if a is greater than 0, or if h is positive, it is obtained by shifting the graph of y equals x squared by h units to the right. Again, if the value of your h is positive, it shifted h units to the right. The graph of y equals quantity x plus h squared, or if h is less than 0 or negative, it is obtained by shifting the graph of y equals ax squared by h units to the left. Example: write the equation for the parabola described using y equals 2x squared as the guide function. Number 1. The graph of a quadratic function is shifted 3 steps to the right. The equation of the parabola will be y equals 2 times quantity x minus 3 squared. Since the graph of the quadratic function is shifted 3 steps to the right, then the value of our h is a positive 3. And by using the guide function, where a is equals to 2, we arrive with our equation of the parabola y equals 2 times quantity x minus 3 squared. Number 2. The graph of a quadratic function is shifted 7 steps to the left. The equation of the parabola is y equals 2 times quantity x plus 7 squared. Since the graph of the quadratic function is shifted 7 steps to the left, we could say that the value of our h is a negative 7. And by using the guide function y equals 2x squared, where a is 2, our parabola, or the equation of our parabola, is y equals 2 times quantity x plus 7 squared. Number 3. The graph of a quadratic function is shifted 13 steps to the right. The equation of the parabola will be y equals 2 times quantity x minus 13 squared. Since the graph of the quadratic function is shifted 13 steps to the right, we could say that the value of our h is a positive 13. And by using the guide function y equals to 2x squared, where a is 2, we could write that the equation of our parabola, or we could say that the equation of our parabola is y equals 2 times quantity x minus 13 squared. Translation of the graphs of the quadratic function, Part 4, effects of changing the value of both h and k. In the previous lesson, we have discussed the effects of changing the value of h. This time, let's have them both, h and k. The value of h equals 0 and k equals 0, we have y equals x squared. If h is 1 and k is 2, we have y equals quantity x minus 1 squared plus 2. While if h is negative 1, k is negative 2, we have y equals quantity x plus 1 squared minus 2. Refer to the table in the next slides and observe the values of y. So here we have y equals x squared, where h is 0, k is 0. So let's have the value of x, negative 2, negative 1, 0, 1, 2. And the values of y respectively are 4, 1, 0, 1, 4. And if we tend to graph this equation of the parabola, or this quadratic function, we will arrive in this graph. The values of our domain and range in graphing the parabola. Number 2, for the color blue, y equals quantity x minus 1 squared plus 2. The values of x are negative 1, 0, 1, 2, 3. And the values of y respectively is 6, 3, 2, 3, 6. H here is positive 1, k is 2. And if we graph this one, the colored blue graph represents y equals quantity x minus 1 squared plus 2, while the black graph represents y equals x squared. Next, y equals quantity x plus 1 squared minus 2, where h is negative 1 and k is negative 2. The values of our x are negative 3, negative 2, negative 1, 0, 1. And the values of your y respectively are 2, negative 1, negative 2, negative 1, 2. So if we graph this one, we arrive with this. The color red graph represents y equals quantity x plus 1 squared minus 2, where the value of your h is negative 1 and k is negative 2. Graphically speaking, the graph of y equals quantity x minus 1 squared plus 2 is the same with the graph of y equals x squared, except for the fact that it shifted 1 unit to the right and 2 units above the x-axis. And it has a vertex of 1, 2, and an axis of symmetry of 1. While the graph of y equals quantity x plus 1 squared minus 2 is similar to the shape of y equals x squared, except that it is shifted 1 unit to the left and 2 units below the x-axis, and it has a vertex of negative 1, negative 2, and an axis of symmetry x equals negative 1. In general, the graph of the function y equals a times quantity x minus h squared plus k, where a, h, and k are real numbers not equal to 0, is the same as the graph of y equals ax squared, except that its vertex is h units to the right or left of the origin and k units above or below the origin. However, if A is positive, the parabola opens upward, and if A is negative, it opens downward. Example A. Direction right, the equation for the parabola described using y equals 2x squared as the guide function. Number 1. The graph of the quadratic function is shifted 5 steps to the right and 5 units above. The equation of the parabola is equals to y equals 2 times quantity x minus 5 squared plus 2. Since the graph of the quadratic function is shifted 5 steps to the right, that means that the value of your h is positive 5 and 2 units above, then the value of your k is positive 2. And by using the guide function y equals 2x squared, where a is 2, we arrive with the quadratic function y equals 2 times quantity x minus 5 squared plus 2. Number 2. The graph of a quadratic function is shifted 4 steps to the left and 3 units above. The equation of the parabola is y equals 2 times quantity x plus 4 squared plus 3. Since the quadratic function is shifted 4 steps to the left, then the value of your h is negative 4 and 3 units above. So, the value of your k is positive 3. And by using the guide function y equals 2x squared, where a is 2, we arrive with y equals 2 times quantity x plus 4 squared plus 3. Number 3. The graph of a quadratic function is shifted 9 steps to the left and 3 units below. The equation of the parabola is y equals 2 times quantity x plus 9 squared minus 3. Since the quadratic function or since the graph of the quadratic function is shifted 9 steps to the left, the value of your h is negative 9 and 3 units below, then the value of your k is negative 3. And by using the guide function where a is 2, so you have there y equals 2 times quantity x plus 9 squared minus 3. Example B. Write the equation of the parabola, that is a transformation of y equals 2x squared and has the minimum or maximum value of the given point. Remember or take note, the minimum or maximum point represents the vertex. If it is minimum, it opens upward, and if it's maximum, it opens downward. That means if its minimum opens upward, the value of your a is positive. And if it's maximum, it opens downward, the value of your a is negative. Minimum point 3, 8. That's your vertex. The equation of the parabola is y equals 2 times quantity x minus 3 squared plus 8. Because the minimum point of the parabola tells us the vertex of the parabola and it opens upward where a is positive, that means your a here is positive 2. And at the same time, the minimum point or the vertex 3, 8 tells us that h is 3, k is 8. Number 2. Maximum point negative 4, negative 3. The equation of the parabola is y equals negative 2 times quantity x plus 4 squared minus 3. The maximum point in a parabola tells us the vertex of the parabola, and that opens upward where a is negative. That means a is negative 2. At the same time, the maximum point or the vertex negative 4, negative 3 tells us that h is negative 4, k is negative 3. So the equation will be y equals negative 2 times quantity x plus 4 squared minus 3.